Les LUT sont très importantes dans le système COSPACER-SAT car ce sont elles qui reçoivent les signaux en provenance des satellites et qui décodent ces signaux et qui traitent le signal de façon à calculer la position de la balise.
The MEO started in, I think, early 2002, maybe 2003. And slowly we build up a momentum that, hey, this is an idea can be done for instantaneous detection of the beacons. We were part of the team to doing a proof of a concept. So from the beginning, we got involved and then put a proof of concept ground station for them down in Goddard Space Flight Center. So that was the first one, the actual running ground station to prove that it works through the satellites.
When the signal first comes down and it hits an individual MEO LUT, that is totally automated. There are no people associated with a MEO LUT. Ironically, it's probably just a rack of computers.
Yeah, so the future MEOSAR ground stations, called MEO-LUTs, are different from their current counterparts, LEO-LUTs and GEO-LUTs. Well, first of all, the GEO-LUTs, they're collecting data from geostationary satellites, which are, for all intents and purposes, stationary. For the LEO-LUTs, so you have a LEO-LUT, they're tracking a LEO pass, the satellite comes overhead, it collects data for about 15 minutes, and then it waits for the next pass. For MEOSAR, it's quite a different thing. What we want to do is try to collect beacon bursts from multiple satellites and collect it through multiple antennas. So these antennas will be continuously tracking satellites over time, getting at least 3 satellites to collect the same beacon burst so we can generate a location.
All the satellites currently operate in MEOSAR are compatible with the ground stations that we've developed. Our ground stations know each satellite's constellation's downlink frequency and polarization, and they're effectively able to track and receive distress signals from GLONASS satellites, the Russian Federation, Galileo, European Union, and the STAR satellites in the GPS constellation.
All right, this is a GEO antenna. It concentrates on the geostationary satellites that's up in space. Those satellites move with the same rotation as the Earth does, so this antenna can stay stationary. Okay, the smaller one behind me is the LEO antenna, and those actually move, and they lock onto the satellite, and it takes the passes as they go by. Okay. And the large one in the back is the MEO antenna. Those are enclosed because they actually move. So you have to protect them from the weather because of the moving parts.
So in a typical MEO-LUT installation, you would have anywhere between 4 and 6 antennas. You can see them behind me right now. And here at the Shirley's Bay MEO-LUT, which is located in Ottawa, we have 6 of them. There's a few over that way. You can see 2 or 3 behind me. These dishes are typically 2.4 meters in size, so they have enough gain so you can actually pick up the signals from the satellites. So currently right now you can see them tracking different satellites because they're at different angles. Most of them are picking up the GPS S-band satellites, which are in our view, in our area here in Ottawa. A couple of them are picking up Galileo right now. Later on they'll pick up a GLONASS when it's in view. And what they do is they take the signals coming in and locate them. These ones here in Ottawa are on towers. They're above the fences and above the tree lines, so we have no blockages. So you always want to have a clear line of sight between yourself and the satellites. From our one spot here in Ottawa with these 6 towers, we can actually cover detection all over Canada's area of responsibility, which is approximately 20 million square kilometers. There's been the idea, of course, as we get all these constellations, the GLONASS, Galileo, and GPS, we could have anywhere of 70, 72 satellites, in which case you may be seeing 15, 16, 17 satellites at any given moment from your ground station. So to be able to pick up all those satellites or see them from your ground station. There's been an antenna system now deployed by France at their LUT, which uses phased array technology. So basically, instead of having unique satellites like dishes that we have right now, where you have a dish that tracks one satellite, this panel, this array of sensors picks up all the energy from the various satellites that we see, and then we'll use that to determine where the beacons are. And it's something that's showing great promise right now, and this is something that we see, being used more and more in the future.
With the MEO, we are actually expecting more faster, timely alerts and more location accuracy. This is the one that we are mainly looking at. Of course, the other one will be how the new generation of beacon will be able to integrate with the new MEOSAR system that will actually help them very much in improving the capability of any beacon distress alert.